A 10 lakh rupee drone destroying a 100 crore rupee system. This is not rare anymore. This is becoming normal. For decades, warfare was built on a simple belief. The more advanced your technology, the stronger your military. Nations invested billions into building the most sophisticated fighter jets, the most accurate missiles, and the most heavily armored tanks. The assumption was clear: better technology equals victory. But that assumption is now breaking. What is replacing it is not just cheaper weapons. It is a completely different way of thinking about war. A system driven by cost efficiency, scale, and rapid iteration. Modern battlefields are showing a clear pattern. Cheap drones, improvised weapons, and rapidly modified systems are no longer secondary tools. They are becoming the primary force shaping outcomes. The shift is simple to understand, but difficult to accept. War is no longer about building the best system. It is about building enough systems, fast enough, cheap enough, and improving them faster than your enemy can respond. Traditional military systems take years to develop. They go through long cycles of design, testing, approvals, and procurement. By the time they are deployed, they are already optimized for conditions that may have changed. They are powerful but slow. Now compare that to a low-cost drone. It can be designed in weeks, built using commercial components, modified in days, sometimes even in hours. If it fails, there is no long investigation cycle. There is no hesitation. You simply build the next version. This creates a powerful feedback loop. Failure leads to learning. Learning leads to modification. Modification leads to redeployment. And this cycle repeats continuously. This is what can be called the iteration loop. And today, this loop is faster than traditional military development cycles. Speed is beginning to outperform sophistication. Now let's look at the economics behind the shift. A high-end military platform like a tank or advanced system can cost tens or hundreds of crores. Because of this, it becomes a protected asset. Commanders hesitate to expose it to high-risk situations. Deployment decisions become cautious. The system is optimized for survival rather than aggressive use. But a cheap system changes everything. If a drone costs 1 lakh, 2 lakh, or even 10 lakh, it is no longer something you protect. It is something you expend. This changes battlefield behavior completely. Cheap systems allow high-risk operations. They allow aggressive tactics. They allow continuous pressure without worrying about individual losses. Instead of relying on one perfect strike, you launch hundreds of imperfect attempts. And statistically, some of those attempts will succeed. This introduces a new way of thinking. Cost per kill. If destroying a high-value asset requires multiple low-cost attempts, but the total cost remains significantly lower than the target, the attacker gains a massive advantage. The battlefield becomes an economic equation, not a display of technological superiority, but a calculation of efficiency. Now comes the second factor: scale. Advanced systems are limited by complexity. They require specialized materials, skilled labor, long production timelines, and strict quality control. This makes them difficult to produce in large numbers. Replacement is slow. Losses are difficult to recover from. Cheap systems do not face the same limitations. They use widely available components. They rely on simpler manufacturing processes. They are often modular, meaning parts can be replaced or upgraded easily. This allows them to be produced in large quantities. And more importantly, replaced continuously. Even if each individual unit is less capable, the collective effect becomes powerful. When hundreds or thousands of systems operate together, they create pressure that even advanced systems struggle to handle. This is where quantity begins to act as a new form of quality. Now we reach the most critical factor in modern warfare: adaptability. Traditional systems are rigid. Once deployed, changes are slow, expensive, and often require centralized decision-making. Cheap systems are flexible. They evolve in real time. Operators in the field modify them based on immediate needs. Engineers update designs continuously. Software can be improved without rebuilding the entire system. The system is no longer a finished product. It becomes a continuously evolving platform. This is where the role of engineers becomes more important than ever. Because the side that can observe faster, learn faster, and adapt faster gains a compounding advantage over time. Every iteration improves performance. Every failure contributes to the next success. Now combine all three elements: low cost, high scale, fast iteration. You don't just get cheaper warfare. You get a completely different kind of warfare. A system where low essays are expected, not feared. A system where speed matters more than perfection. A system where continuous adaptation becomes the core strategy. This does not mean advanced systems are irrelevant. They still provide strategic reach, precision, and deterrence. But they are no longer sufficient on their own. Because a high-cost system cannot be everywhere at once. But thousands of low-cost systems can. And that changes control of the battlefield. The real transformation is not just technological. It is philosophical. War is shifting from perfection to iteration. From protection to expendability. From limited assets to scalable systems. The side that understands this shift first does not just fight differently. It wins differently.